Hello 108 students, Mr. McHugh here with you. Continuing our work on section 2.2, and we're going to go ahead and tackle page 2, and that's going to wrap up this section. So we got another example here of a formula for the area of a surface area, the area for surface area formula is what I'm trying to say. And think of a box. If you get something from Amazon, it comes delivered to your house. It's got length, width, and height to it. And what would be the surface area? What if you're going to cover that up with wrapping, Christmas wrapping paper, and you were going to cut out sides to go around the fronts, the backs, the sides. Here's the sides. And finally, the back would be over here. So the question would be, how many sides are there to a box? And the answer is 6. If we wanted to figure out the surface area for it, we would realize that height times the width would be the left side and the right side. Length times the width would be the bottom and the top sides, and length and height would be, here's length, here's height, that would be the front and the back. Okay, and notice if you're going to calculate the area, it's length, it's the one side times the other side, and then you double it because there's two of them, a front and left side, right side, back side, bottom side, top side, front and back. And so that's how they came up with the formula. So I want you to feel comfortable with that. Okay, now our challenge is in this problem, can we isolate and find what L equals? What would L equal if we could isolate it? Now this one looks a little tricky when you first start it. However, I notice L is in what terms? It's over here in these two. So I say the 2HW and I subtract it from both sides. And that left me area minus 2 times the height times the width equals. Then what I did over here was I pulled out the 2L. Greatest common factor, GCF. I pulled it out. This does not belong here. It's 2 times L, and that was times what's left. When you pull out the GCF, it's the W and it's the H. They come in there. And so once I've done that, I realize I got multiplication going here, and that's kind of good because when I pulled out the GCF, L is part of it. And so you get multiplication over here, so I'm going to go ahead and divide both sides by the parentheses W plus H. I'm going to divide it on both sides. Now you got to leave everything on the left hand side the way you see it. Over here these cancel out, and so now you're left with 2L equals the left hand side. Now a shortcut here is I said divide by 2 to isolate. That's true, that's normally what you do. But I'm going to recommend that you think of multiplying by 1/2 on both sides. And that's what I did over here. I multiplied by 1/2. So 2 over 1 times 1/2 cancel out because it equals 1. And you're left with isolated L for the length. And you take the whole quantity, area minus 2 times the height times the width divided by the width plus the H. And you multiply that all by 1/2. Okay, that one gets a little wordy to talk about, but so when you practice those problems, think of that reverse distributive property. That's the key part on that problem. Okay, now a couple more easy examples. Oops, I did it again. To work on is what happens if you are out traveling in your car, distance equals rate times time. You're told that Janet takes 3/4 of an hour to travel a distance of 15 miles, and you wonder what her speed is. Okay, and so one way to do this, and they're trying to get you to practice isolating variables, is distance equals rate times time. Isolate the R for the rate. And I like this idea because you don't have to memorize all 3 of these equations. You just have to remember that distance equals rate times time. So if I divided both sides by t, for time, it would cancel out on the right and leave me the distance that you traveled divided by the time equals the rate. Okay, so I come in here and I write the 15 miles that's given to you. I write 3/4 of an hour. We're talking about miles per hour, so you leave as a fraction there. And then I'm trying to remember what to do with what happens if you have a complex fraction and you divide by in the denominator is 3/4. You multiply by the reciprocal. So here's 5, here's 15 times the reciprocal, 4/3. That will equal the rate. And I have a fraction here, so I think 15 divided by 3 is 5. 5 times 4, and there's your 20 miles an hour that you're going. Okay, it's just a couple problems there to keep you going here. Example 5 real fast is what happens if you have a 50 liter, the little L stands for liter, mix of some acid and water, and 10 liters out of that mixture is acid. What is the percentage of them? I think of these as a proportion where you've got the part over the whole, and I come over and I realize they give you 10 bags, 10 liters divided by the 50 liters. The zeros cancel out. 0 divided by 0, you can cancel them out, and you're left with 1/5. That happens to be 0.2. You can do that on your calculator or do it longhand. You remember how you do that? 1 divided by 5. Put the decimal, bring it up. Look at this as a whole number. 5 goes into 10 2 times. Okay, and when it's 0.2 and they ask for percent of the problem, you've got to move the decimal 2 places to the right, and you got your answer of 20%. Okay, hey, that's going to do it for page 2 here, wrapping up section 2.2. So we will go ahead and I'll see you on for section 2.3. Okay, I'll see you later.